All right, so the question is, how many triangles are determined by the vertices of a regular polygon of n sides? How many if no side of the polygon is set to be, how many if no side of the polygon is to be a side of any triangle? This is in section 1.3, number 21. So let's try to get an idea of what's going on here. We've got a polygon with however many sides. Maybe a lot of them, maybe a few of them. And the question is, I've got n vertices. How many triangles are determined? Well, a triangle looks like this, right? Now that one happens to use an edge of the polygon, but I could also just do something like this. And that one doesn't use an edge of the polygon. So the first question is pretty easy. How many triangles are determined by the vertices of a polygon with n sides? What do you think it is? And choose 3. As soon as you choose 3 vertices, you get a triangle. No matter which 3 vertices you pick, you form a triangle. So the first part, if you want to call that part A, call this part B, the answer to part A is just n choose 3. Yeah? The intersects? So the 2 I've drawn here, these intersections? No. We're counting triangles. So we count that one and then we remove it. And then we count the other one, and then we remove it. We count another one. We're not drawing a whole bunch and counting how many triangles are there. It's how many triangles exist where the vertices are points on the polygon. Okay, so n choose 3 is pretty straightforward. The second one, though, part B, is how many if no side of the polygon is to be the side of any triangle. Okay, so in other words, the triangles I'm counting do not include that one. Right? That is now no longer a valid triangle. That one includes a side that's on the polygon, but this one's good. Okay? Yes, exactly. And so the easiest way, in my mind, to do this, and I think this is what the solution does, is to count the opposite, which is you're gonna find all possible triangles, and you're going to get rid of ones that actually have an edge on the polygon. Okay?
Hey everybody, let's take a break from the example for a sec. The example I'm doing here is really just a single example, and there are literally infinitely more problems you can run into on a discrete math exam. And odds are good you'll run into problems you've never seen before and be expected to apply what you know to solving them. But if you don't understand the content, you have no hope. So if you're taking a university, if you're a student taking a university discrete math course, and you're serious about not just getting a good grade, of course, yes, getting a good grade, but if you're serious about understanding the content, then go ahead and click the first link in the description down below and book a free call with me. Now, back to the example.
And so we know from part A is just n choose 3. That's how many there are in total. And now what I'm going to subtract off is all the ones that overlap. Well, okay. First step is which edge? So for instance, if I look at, let me use a different color here. This edge here. How many triangles overlap with that edge? Well, there are n points in total here, and I've used those 2. So it has to be n minus 2 others can be added, right? Any one down here, you just pick that point and then you join up the lines and you get, and there are n minus 2 choices that use that edge. Except, well, okay, well, keep going then. Now that's how many with that edge. How many with this edge? N minus 2 again. Except, hold on. Except you've actually double counted, because there's one triangle that uses both those edges, right? And so this is where you got to break it into parts. Break it into different sections. So let's deal with triangles that overlap in exactly one edge first.
Hey guys, if you are looking for help with learning discrete math or proofs, I know they're tough, then make sure to subscribe, as I'm literally going to be posting every example I have here for free on YouTube to help you learn and understand discrete math proofs. Back to the example.
Okay, how many overlap in exactly one edge? Well, first off, I got to choose the edge that's going to overlap with, right? And then, and how many ways can I do that? There are n different edges going around. So choose the edge you're going to overlap with. And then how many vertices are there that would make the triangle? Not n minus 2 anymore. Because n minus 2 includes this guy. And that's not allowed anymore because that would overlap in 2 edges. Not n minus 3 either. N minus 4, because this one's bad and this one's bad. Right? So there are n minus 4 choices. You can't choose this one, you can't choose this one, but you can choose any others. And so once you choose the edge that's going to overlap, there are n minus 4 options to go along with that. So this is overlap in exactly one edge. This is choose which edge. This is choose third vertex. Okay, so that's the ones that overlap in exactly one edge. What about now the ones that overlap in exactly 2 edges? Well, so you know it's going to be 2 edges right beside each other immediately. Okay, and how many ways can I do that? N times, yeah. You choose the edge to the left, and then take the edge to the right of it. So choose the edge to the left first, and always take the one to the right of it. How many ways can you do that? Well, every edge. Once you pick every edge, you get the one to the right of it, and those are all different. So there's n different ways to choose that. So we first choose the 2 edges. There's n ways to do that. And then, yeah. Well, great question. Can we ever have where you've got a triangle, but the 2 edges that are overlapping it are this one and this one? And you realize very quickly, no, you can't do that because you're involving 4 vertices. How can a triangle involve 4 vertices, right? Okay. So there are n ways to choose the 2 edges. And then how many ways can I finish that triangle? One way. Just draw the line. Right? And so there you go. There's n ways to choose the 2 edges it overlaps. And that's it. Because once you choose those 2 edges, the other one is guaranteed. Has to be. Oh, well, that's the same thing. Like, so any 2 edges that are beside each other, I chose this one, and then I chose the one to the right of it. If I want this edge over here, I chose this one, and I chose the one to the right of it. Okay. So that's the point. Now, I can't overlap in 3 edges. Agreed? Is that clear? If I overlap in 3 edges, what would that look like? I mean, 1, 2, and then the 3rd edge has to complete the triangle. And so I need to go back. To the triangle. So no. So that's it. That answers the question. That completely solves the problem because I've taken every possible triangle. I subtract off ones that overlap in exactly 1 edge. I subtract off ones that overlap in exactly 2 edges, and there you go. That's all the ones that overlap. So we're done. Okay.
Hey, thanks for watching. Remember, what I've explained here is just a tiny, tiny example in the literally infinite space of problems there could be that you'd run into. So, if you're interested in really understanding this content, getting a good grade because you understand the content, go ahead and click the first link down below and book a free call with me, and let's talk about if I can actually help you do well in this course.